Today's date is the 21st of March 2026. Time now is midnight Friday, no, Saturday 21st of March. Time now is midnight 13 minutes past midnight. And this is the how to build a wormhole. Um the wormhole is exists in two ways. You can have a ring space, basically Cartesian model, a polar ring space. Basically, the ring space is by definition is a ring and a space. So think of it as polar region, and you got point space, which is Cartesian space. Any kind of traits that lie between the polar space and the Cartesian space is defined. It should be planetary ring shape and point space. The basically the model is gonna express that ring space is a polar coordinate system. Can be Euclidean or non-Euclidean geometry or space, and point space is Cartesian properties or traits that behave in a structured, deterministic way over the two models of space. Furthermore, it's very important to understand that the ring space and the point space are just models of space. You can create your model of space, but they are the standard. I'm trying to standardize the space model based on the point. What's a point? What is a point in space? For example, you have a ring space, non-Euclidean geometry via hyperbolic space, hyperbolic geometry, such that there exists a line that exists across all points but doesn't intersect all points. So no point. Will be wrong. Example: what does this mean? I can demonstrate a line in a hypothetical framework, and that line does exist as a and the axiom does hold. A line can go through a point don't intercept as part of a hyperbolic space. And I'll prove that now were informally via the non-Euclidean geometry space. Hyperbolic space is a geometric space that is more spacious than the original space, but not as expensive as the hyperbolic plane. In hyperbolic space, light travels in a path that's perceived as a curve. Although it is straight according to geometry of the space, the concept can be visualized across the cosmic eyes looking at distance of the space. We compare to everyday life. So the thing you can understand about hyperbolic space is everything have a trajectory, and that trajectory is basically spacious. So space is a spectrum. It is not a linear system. And the hyperbolic geometry of space can determine basically if you got a light, if you got a photon, and the photon is the fastest in the universe. What does that mean? It means it's at every angle, every medium, it takes the shortest path. And the shortest path is a Hamiltonian graph can be drawn out, can be treated in a Hamiltonian graph, Hamiltonian path, and without picking up a pen. And by not picking up a pen, you can always trace it back. So you get front and back. You see, it's not about wave quantum duality, or but the system has to understand that light goes through space through medium because it's just part over the hyperbolic plane because it's massless. It doesn't want to hold any reference to the ball observer, as you call it. Furthermore, my point is to give you a system of explaining this kind of phenomenon. So you get this paper here, and I can draw three lines without picking my pen. So if I can draw a circle without picking my pen, what does it look like? So a circle without a circle in 1D space will look like this. I take a color on my edge, I take an edge, I take an edge, I put it down in center, I put it down, and I put it down. I go here, draw a circle, I draw a line, and I draw a circle without picking up a pen. Uh, uh, I draw. Sorry, I draw a circle like basically I can draw starting from the center, draw a circle without picking up a pen, and so I take a dimension, and I fold it in, and I fold it in. You see, this dimension. See, it comes from the edge. So I find an edge of a system, and I typically it may not understand where I'm going with this, but the framework shows that I take an edge, something like a point in space. I pick an arbitrary point. I collapse the point into the center of the ring or the circle, the radius r of pi r squared, and then I trace the edges of the system. Now, I call it tracing because we don't need the properties when it's done, when the computer is done. Because if you ever draw the line, we are tampering with our fabric of space-time. And this page dimension is just like a ruler that can draw to 2 pi r. So basically, I think it is a piece of sheet paper. I folded it in 50 degrees. Now I get two sides. I can draw anti-clockwise or clockwise, and then I can leave the division here. I can draw a full 270-degree arc, anti-clockwise or clockwise, and this is a circle that can then leave the space and then draw the final 90 degrees angle. So that's one way to do it. So draw without putting it. Now, if I want to draw a square with three lines, I use the process. I take this paper, I fold it in, I go 1, 2, and then I fold it in 3 and 4. So this square exists on the surface level, and I can see this circle. My purpose to explain this square now. The square I drawn on the outside sheet of paper, the A4 sheet of paper here, it has it's basically on another dimension, as different dimension as the so this is the dimension of the square I drew on, but I had to take this paper, explode the dimension, explode the places of the paper dimension to draw a square with three lines. 1, 2, 3, 4. Three lines. 1, 2, 3. Because I cannot draw a square without basically to draw a square with three lines. You take the page of the A4 piece of paper, you then draw the circle on the square, but the square so you start from the center of the square circle, and you go right on the folded piece of paper, and you come down right on the you then do two more lines, 1, 2. So you drew a 90-degree angle from the circle when you stopped down all the way 90 degrees into the indirecting back into the going at right angle counterclockwise back into the circle. I can draw one more line. So you don't need three lines to draw this square. But I use the dimensions of the space to elevate my ideas and my dimensions. The paper is still there, and the paper still right, but I did not. I use one less line. I use one less line and one less arc. and that arc was at 90 degrees. So I can use one less line in 2D. In 2D, if I have a 2D one less line, so basically I go for formally, you can use one less line in 2 dimensions to create a wormhole bridge. And that one less line, I can usually one more line. I mean, use one more line. Use one more. Sorry, use one more line in 2D to complete a travel, and that travel is not punctured in space and time. It's not punctured in space and time. It's literally using auxiliary construction of auxiliary space, but using another dimension of reality, using another dimension of reality to do it. The dimension of reality is space on top of it. And the space on top of it is literally the dimension that we all share and never use, and you rarely use. Okay. So we all have you have for every path you take, every way there is to go, like left, right, and center. Every path way there is to go, and every shape or structure that dictates that defines the shape of that path. There's something we share and we rarely use. We hardly use in space, as based on our observer model. And this is why this crafting is happening, because we live with spread out. The light is hyperbolic. It's a hyperbolic system. The wavelength light is a spectrum, and the fastest travel is a spectrum. The light behaves on a spectrum. The trait is on a spectrum. The behavior of light is on a spectrum. Space light is made of white light is made of all the colors of rainbow. It obeys laws. It doesn't need to. It's the fastest thing to move in the universe, and it's faster than that's we can think it's a stainless because it doesn't need the observer to collapse or take a measurement. It doesn't need any kind of it just likes to be. It just bees. It just belongs to the system. So the people. So we get teleportation. Okay, but the wormhole has to be stable. So the wormhole you have to project. So how would it be stable? So you get if you think about the other model of a front and back, front and back, you have the same thing. So if I wanted to take this paper and rotate the other side, I have a front and back. See, I have a front and back. So I have to rotate my dimensions 180 degrees on the z-axis, because on the y-axis. Yeah, so I have to shape my frame of reference, y-axis, by rotating the paper, and that paper will allow me to bridge the two sides of the reality. So you're gonna get 3 lines. That put your pen, 3 lines. So basically, I draw 1, 2. I pick up, I can't pick up my pen, so I fold the paper, and also I do 1, 2. Now I get square. But I drew it because as one consecutive line because it's a different dimension. Basically, how to draw a line without picking a pen? How to draw with 3 lines? The 3 lines. How to draw a square with 3 lines without picking up your pen. So you have to not pick up your pen to do it. You have to draw a circle too. You can do a circle, but you cannot move. You cannot pick up your pen because it's a Hamiltonian path. And if you ever pick up a pen, some will break and will never stabilize. So you gotta stand. You take the rotation. You gotta be on the side, and it's not a rotation. So for me to now flip it after now just rotate the version. It's like it's like me a spinning wheel, spinning something. So, for example, you have a Hamiltonian path A, and you want to get to B. You can walk all the way there to B, which is like 5 kilometers, or you can rotate on axis Z. So the first way to find the vector. My computation, you're gonna find the vector Z that projects A. So AZ projects a shadow to Z. Okay, Z. Basically, if you have a point A, you have a vector. If you have a point A, B, a point A. If you have a point A, if you're on a space A, A, B, AB, AB. AB is a vector. You're trying to project yourself to point CD table. So AB is a vector, and if you're okay, sorry, if you're on point A, I wrote it down properly now. If you're on point A and you go to point B, and it's 5 kilometers away, you have to find a 5 kilometer vector in RZ in RZ in RZ. RZ represents the row spaces of Z. Now, Z represents the axis of the Z coordinate that will rotate your that will rotate you. So you can compute. No, if you don't have Z, you have to compute RY. Let's see. If you compute a vector of R space, you can compute. You want you see it can be rotated easily. You rotate your axis from the A with a point to B, but you rotate anti-clockwise to get to B. So when you find the projection, the shadow of the projection of V, you of a vector defined as P. That P is basically the B. You can then map. Then you can then that's your bridge. So P is your projection vector, and that projection vector is your system, and you can use it to map onto the other side of the system. But you have to map it twice. If you want to come back, you have to map it twice. If you don't map it once, if you map it once, you are just staying where you are. You can't come back because you just locked yourself out of your own system. So you go to have it mapped bi-directional, mapped from here to here. So you can always go back to that portal and you'll be behaving like 2 points in a space. So you get point space, you get line space. Point space, you get point space, you get ring space, usually polar system, polar system. And the goal is to have system have you intersect the line B by rotation because you rotate an axis back and forth, and the system is using the energy because you are you're using a projection to map onto something that was not. You're constructing auxiliary vector that can give you that allows you to move through a space in time. In time, the time you share, will share, will have, so you can go from point A to point B and back. So you get RX, R1, the row space X and it goes to map a direction. So basically, the more dimensions you use, that's because you are the easy computer you get, But the goal is to have this predictive point computed, such that this is the line. Basically, you're basically trying to compute the right angle if you're using a square. Or the rectangle doesn't matter what you're trying to shape you use, because the line space is the line space is a square and the space is a circle, and the circle basically can be a 3D circle. The more you can create this corner, this bridge, the more you can, the more places you can go. Thank you for watching this video.